Write down the reason. On the basis of the information above, X is the number, okay? Why is not X is the number of times that head is uppermost?
It also can be 0, 1, 2, 3, 4, 5.
Okay, because there are more than one outcome, okay? For
More than
X.
2.
More than 2, because there are more than 2 outcomes. Okay? Okay, now, part B, what is the mean?
0.2.
Okay, you know how to count, everyone, I don't have to show already, the formula. Okay, number 2, the standard deviation is 0.4. Okay, and C, when P equal to 0.5. Right?
Yes.
Okay, done. So we move on to the question 3. Okay, so this one is a normal distribution, correct? So you just use normal CDF. So the first one, the answer is obvious. Yeah, because 37 is the mean. So the mean is also the median. So the probability is 0.5. And part 2,
But they want proportion, so 50%.
Teacher.
Yes.
Teacher, like for the mean, because the mean is NP, and then
Wait,
like,
how come the mean is NP? Why the mean is NP? This is not binomial, no. This is Bernoulli, no. The n is 1. You are talking about number 2, correct? This is Bernoulli. Bernoulli, the n is 1. Am I right? Okay, Bernoulli, you have only 2 outcomes. This is your X. We use the logic 0 to represent no, logic 1 to represent yes, correct? Then probability of 1 is 0.2. Probability of getting 0 is 0.8. So you use the mean formula, 0 times 0.8 plus 1 times 0.2. Isn't it 0.2? Hello? Are you okay? This is Bernoulli. Are you okay or not?
okay.
Okay, Okay. So for part 2, can I move on to question 3?
And
Can I? Okay. Now for part 3, the answer, part 2, the answer will be 0.0228 after you round off.
but they want in proportion, teacher.
Okay, they say proportion. Okay, this is 50%. This is 2.28%. Okay. Okay. Then part B, you get the confidence interval for mean is 36.719. If you don't understand, you better ask me how to get the answer. I'm just giving you the answer. So then you have to say we are 95% confidence. Okay, that one everyone know how to answer already. Okay. Any issue with that? Okay, now this is part 1. Okay, part 2, I need you to tell me what is the answer for part 2. On the basis of the confidence interval you found in part B1, explain whether or not the 1992 data are consistent with the mean of 37?
No, because
No.
the highest estimated true population mean body temperature in 1992 is 36.9 degrees Celsius, which is lesser than 37.
Yes, you are right now this time, right? So that means they say the body temperature is consistent, means it's the same, can be the same, but it's not. It's a bit lower, 0.1 degree lower, correct? Because the highest predicted here. This is the highest predicted. Yeah. Okay, huh? So the answer is not consistent, huh? Consistent means stay the same, okay? Can I? Okay, can we move on to question 7? Yeah, question 7. Okay, so part 1, these are very common question, correct? A will be equal to 5/6. Okay, part A, huh? Okay, part 2, the mean is 1 and 19/30. If you get decimal, also doesn't matter. Yeah, you know how to get the mean, huh? Okay. Then part B, the expected one is the same, correct? You have any issue with this? It's also 1 and 19/30. You get from, because this table is exactly the same as the one given, correct? In part A. Yeah. Okay, huh?
Teacher, but then this one, I thought you need to, because the probability is not 1, or the total probability.
So,
So you must like, the one you lose also, the one you used to play the game,
0 ma, you didn't get anything ma?
but then you pay 2 or 2 token.
Okay, let X represent the number of token won. Read carefully the question. And number of token won, that means when you play this game, how many token you will get. It doesn't matter what you pay. You are not talking about the net token won. Josh, do you get me?
Yeah, can.
Okay, huh? That's why they give you 1 mark only. Correct? Okay, now, in one day, the game is played 1,000 times. Okay, predict whether or not the operator will have more token or less token at the end of the day. So how are you
More
going
token.
to more
Because
token?
in the long run, the operator is expected to earn
Earn?
0.37 token per game.
Yes, correct. In the long run, the owner, okay, the operator is expected to earn, to have. So you just take 2 take away 1 and 19/30. This is the one that he received from the player. This is the payout. Correct? Okay, so you got 11/30. Correct? Per game, per player, per game. So at the end, you have more token. Correct? Okay? That's how you. So how many token, extra token? So they say explain your answer. This is the part whereby I explain my answer already. Okay. Okay, can I move? Okay, we move on to the next one. Okay, question 12. Okay, we move on to question 12. Have you finished question 12?
Yes.
Okay, we move on to question 12. Okay, so question 12 is the sum, correct? So they are talking about, okay, which histogram A or B illustrate the distribution of W? Explain your
Histogram
answer.
B, because it is not normally distributed.
Okay, histogram B. Okay, B is W because it is not normally distributed. Yeah, that is the answer. Okay, so 12A done. B, because it is not, you want to say symmetrical also can, it is not normally distributed. Okay, so let's go to part B. Okay, part B, they ask, is S73, let S73 be the sum of the weight of a random sample of 73 nails. According to the central limit theorem, the distribution of S23 will be approximately normal, provided that the sample size is sufficiently large. Is the sample size of 73 sufficiently large in this case? Explain your answer. Listen, referring to part A as appropriate. So you cannot say by rules of terms of rule, because they say referring to part A as appropriate. Okay, can you give me the answer?
Yes, because 73 is larger than 25 and sample size of 25 is already large enough for CLT to be applied.
Why? Why sample size? What evidence do you have said the sample size 25 is
Because
large
it
enough?
is normally distributed.
Yes, you have to mention that. Are you clear? You have to say yes, because the distribution of S25 in A is normally distributed. And 73 is greater than 25. Done. Are you okay? So the evidence, this is called the evidence. Okay, calculate the mean of S73. No problem, correct? Know the formula. So the answer is 489.1. What is a unit? On nails. No. What is a unit? Gram. Yeah. So I have to write down the unit. Okay, part 3. The standard deviation of S73 will be square root of 73 times 0.17. So it's approximately 1.45 grams. Right? Okay, so part 4. Find the approximate value for probability for S73 to be more than 500 grams. So the answer is?
Is it 0?
Yes, you're right. Because you can see here, if 3 standard deviation away, correct? Actually, I don't have to count already. I times 3, correct? Okay, then I plus to 4, 8. It's around almost 2 to 3 standard deviation away already. So it's almost 0, okay? Yep. Okay, so then they say the nail are sold in a packet of this one. Okay, so now they ask, using your answer in B part 4, state how likely is that the machine will stop filling a packet when the packet contains 73 nails or fewer.
Very unlikely.
Very
because of
unlikely.
probability of sum of 73 nails weighing more than or equal to 500 grams is approximately 0. Hence, more
Yes.
nails are needed.
Yes, you are right. Because you make it as 500, correct? So more than 500, sum of 73 nail more than 500 is 0. So that means the machine will keep filling in. That means in a packet you will have more than 73 nails. Correct? Understand? Very unlikely because probability of S73 more than 500 grams is almost 0. So when it is reached 73 nail, the machine will continue to fill in so that to achieve 500. Yep. Okay, then the label on each packet state contain at least 74. Is this statement reasonable? Justify your claim.
Yes, because a packet of 73 nails is very unlikely to hit the requirement of 500 grams.
Correct. So this time you are okay already, Josh? The rest, are you okay? So if I say contain at least 74, that means 74 and above. Because the machine will not stop at 73. It will continue to fill in until it achieves total of 500. Okay, So we have the last question, is it? Yeah, question 14. Okay, this paper is have a lot of questions is because last time their paper is 3 hours. Okay, question 14. Okay, can you tell me? Answer for A. Haven't finished, is it? You need some time to finish it or we finish it together. Okay, can you give me the answer for A? Properties?
So the first one is the total area below the curve has to be 1.
No, that is not the first one.
The first one is the fx must be equal to or greater than 0 for all values of x.
Yes, that is the first one. Second one?
Second one is the integrate a to b fx dx equals to 1.
Yes. The area bounded by the probability density function must be equal to 1 if you put in words. Okay? Can I? And should we put an upper limit? Should we put an upper limit for the probability?
Upper limit for what?
Upper limit, or this is the lower limit. Is there an upper limit for the probability? Should we put it like that?
But this is fx or not the integrate.
No, the fx function can a probability density be more than one? Like for even normal one.
But this one fx is the y graph.
Yeah,
mah.
lah.
So
Like
unless you
when you talk
integrate, then
about
the area must be one.
no. It cannot be more than one. The value here. This is a probability. This is called probability density function. So this one also cannot be more than one, even for normal distribution. I think we have to put the upper limit. Okay. Like you remember, I give the probability density function as c e to the power negative x. You see the c is 1. Highest is 1. It can never go beyond 1. Correct or not? Still remember that question? So we have to put the upper limit. Go back and check your that one. My answer, I got put the upper limit. So you must say, here it's good to write it like that. Fx must be greater than 0, but less than or equal to 1.
Teacher, but then this one, why the fx cannot go above 1?
If the fx go above 1,
Because you want to find the limit is for the area, not the y also. It's for the area below the y.
like this question, the fx got more than 1.
Got until 2, the maximum point is 2.55.
When x equal to 0, the maximum point is 2.55. So can
Yeah.
go lah.
Because this one, the limit should be the area below the graph.
But when we talk about probability distribution table, that is not probability.
That's for the area.
This is the probability density. But I got put the limit as 1.
I think the limit is for the integrate the area.
I know.
fx cannot.
The fx for this one, the maximum is when x equal to
0.714.
So the maximum is you got the graph already, is it?
Yeah.
Okay. Then we go to part B. You sketch the graph already. 0.714. So the graph for part B, correct? You just key the function in. The graphs look like this. There is an inflection point, correct? Does it look like that?
Yeah.
So the highest point, what is the coordinate? Josh?
0.714. Then 2.55.
2.55. This one I didn't get my answer. I didn't get the highest point. Okay. Yep. Okay, done. So let's go to the next one. Then they say, what is the probability that x is less than half? So you want to do part C, correct? So you integrate from 0 to half. Then your function, you write down the function. The function is okay. This one you key you key in the GC already, correct? Okay, then the x, and you get the answer as 0.667. Is it?
No, I got about 0.145.
No, 0.145. That is the mean. That is the mean. Yeah, you got 0.1445, right? Okay, then when you talk about D, the mean, that means you have to integrate from 0 to 1, x, then this function, the probability density function, then you get 0.667. Am I right?
Yes.
Okay. Then part E, this is mere calculation. When you want to find the standard deviation, you do square root of, you integrate from 0 to 1, x squared, then the function dx, then take away the mean square. Okay, then you get the answer as 0.1487. You get that?
Yeah.
So calculate the mean, done. Calculate the standard deviation, done. Okay? Then we go to part F. Have you done part F?
Not yet.
Okay, you may do part F first. Everyone? Okay, so you just need to do this step. Okay, so they say hence.
Can you go back the previous slide for a while?
Okay.
Okay, thank you, teacher.
Okay, what is your problem?
Oh, no problem, no problem.
No problem. Okay. Okay, can I move to the other one? Okay. F part 1 done. Part 2, because they say hence. So the moment they say hence means they expect you to do by calculus. Okay, so you have to integrate from 0 to median 168 x to the power 5 minus 336 x to the power 6 plus 168 x to the power 7 dx equal to 0.5. You must show this step. Are you okay? So you have to show 168 x to the power 6 divided by 6. Take away 336 x to the power 7 divided by 7 plus 168 x to the power 8 divided by 8. 0 to m equal to 0.5. Okay, then what you need to do is you at least must substitute with m. So 168 m. So I can take out m to the power 6. Am I right? Take away 336 m over 7 plus 168 m square over 8 equal to 0.5. Yep. Then from there, okay, you don't have to solve algebraically. Yep. Then you can straight away find your median using your solver. What do you get? Hmm?
0.679 approximately.
Yeah, you are right. 0.679. Got it? So, last part. What feature of the graph of y equal to fx reflect the fact that the mean of x is less than the median? Hmm? The graph is skewed what?
Skewed right.
Hey, mana boleh. The graph is like that, Lapan. Median is here. Mean is here. This is left. Median is 0.679, correct? Mean is 0.667, correct?
Yeah. Negatively skewed.
Negatively skewed. Skew left, okay? Left skewed. Cannot? Okay. Oh, we still got one more question. Have you done question 15?
Not yet.
This is one of the past year question. Okay. This question is from one binomial get into another binomial. Do you know that? So sample size is 100. X is 87. So part 1, you calculate using one project interval. Yeah, you get this proportion, correct? Am I being too fast? Okay. Give you some time to read through first. Have you got the answer? So the first one, the answer is 0.804. And here is 0.9359. Okay, so you say we are, okay, you can write down all your things. So the lowest is 80.4% to highest 93.6%. Right, not? Okay, so they say on the basis of the confidence interval that on the basis of the confidence interval that you calculated in part A1, the wholesaler claimed that at least 80 of the seed will germinate and grow into seeding. Okay or not? Explain why is it reasonable for the wholesaler to make this claim? Because the lowest proportion is 80.4% in the confidence interval. So it is reasonable to claim that is at least 80%. Okay? Because the lowest possible proportion is 80.4%, which is greater than 80%. Okay, so that means 80 out of 100 seed will germinate. More than 80 out of 100 seed will germinate. Okay, so for part B, they say assume now that 80% of the seed will germinate and grow into seeding. The manager of the plant nursery has purchased this seed and is planning to germinate them in a tray consisting of 6 pots, as shown in the photo. Or only tray with all or more seeding in all 6 pots can be sold. The manager wants to make sure more than 90% of the tray can be sold. So now B, the manager decides to plant 2 seeds, okay, in every pot. So every pot, okay, calculate the probability that if 2 seeds are planted in a single pot, at least one of the seeds will germinate and grow into seeding. So now part 1, we are talking about a pot. So we let X be the what? Number of seed become seeding. Okay, so and in a pot, the number of seed, that is the sample. Okay, the number of trial, there are 2. So the possible value for X will be 0, 1, 2, correct? So that means X is a binomial distribution with the probability, with the n equal to 2, and the probability of success is 0.8. Yeah. So now we want to calculate the probability that each pot, the pot will have a seeding. So probability X must be greater than or equal to 1. Am I right? Are you okay?
Okay.
Okay. So now this one will become equal to, you know what is the answer? Okay, 0.96. Am I right?
Yeah.
Yeah, 0.96. Okay, then we go to part 2. They say using your answer to part B1, calculate the probability that if 2 seedlings are planted in each of the 6 pots in each tray, at least one of the seed in each pot will germinate and grow into seedling. Okay, so that means we are talking about now a tray, right? So in a tray, there are how many pots? So your N is 6. So now your Y is the number of pots with seeding. We don't care how many, right? So the Y can be 0, 1, 2, until 6. So now you want to sell the tray, correct? What is the criteria to sell a tray?
Each pot must have at least 1 seedling.
So that means my Y must be equal to, so what is my probability of success? Here.
0.96.
0.96. Must have a seeding. So Y equal to 6. So what is the answer? Use binom PDF, 0.783. Am I right? Do you get 0.783?
Yes.
Okay, so now, that doesn't meet his requirement, correct? His requirement is what? At least 90% of the tray can be sold. This one only 78.3% can be sold. So now he decided each pot is going to put 3 seeding. So that means for part C, correct? You have to repeat whatever in part B. So you have to do a pot first. Same process. Now the N is equal to 3. So you're finding the probability of X greater than or equal to 1. Okay, can I have the answer? The P is still 0.8,
0.992.
0.992, good. So now you have to repeat the part 2, talking about a tray. The N is still equal to 6 and the P is equal to 0.992. So you want to sell a tray, make sure every pot must have the seeding. Yeah, what do you get?
0.953.
0.953. Yeah. So that means if you put 3 seeding in a pot, 3 seed in a pot, then you can achieve. So if you want to get a higher probability that you can sell the whole tray, you put more seed in. Yeah. So if in the exam, they ask you for example, they ask you, maybe is another question. They say, what should the number of seed put into the each pot so that it can achieve the 90%? So you have to do by try and error. You get me? So remember, binomial distribution, correct? If you want to find the number of N, how many seed, all this kind of thing is good to do by try and error. They always will lead you one. So the second part or the last part, you always look at in front. Hello, remember, binomial can be done by try and error, especially when you want to find N or P. Clear?
Clear.
Okay. So that's all Miss Do can do for you. That's all I can help you. So I hope everyone, you spend your time doing your work. Can or not? So
Can.
far, so good. Okay, so if you have any problem that you wish to ask me, okay, you can ask me. Okay. If the whole class you wish to have another Zoom class before your paper will be on Thursday, right?
Yeah.
So I can't be there. So sorry, because I have a class. I have online class. I cannot run two places unless I have that online class in college. I will see how. If I can drop by, I will drop by. Yeah.